All right, we're recording. Okay, so I'm here with
Cool.
Nicholas, and we're talking about building a little attestation machine where you can basically hide in plain sight your attestation and have the ability to later on prove it. And so, like, you can just like tweet a hash to something, and then later on you could link to it and be like, "Hey, everybody, it's all on chain. Here's my attestation," not just on Twitter, but like in a smart contract. And you can go verify basically the reveal eventually. And we're just going to use the Catch Act 256 and a smart contract and some scaffold-eth and just kind of wire it up.
Exactly. So you'll be able to like
Yep.
post a secret and then later on reveal it. And maybe if somebody thinks they know your secret, maybe they can try to reveal it. So it's not only the owner that can do it, but just anybody could reveal that secret. I guess
Yeah.
we'll see if that's a good idea
Yeah.
as we think through it.
So let's look at just getting the hash function working first, right? So let's go to our smart contract and do like maybe make a get hash function where you put some value in, some string in, and you get back like the catch act 256. You can even take out those fallback functions. Probably you probably don't want this thing to receive ETH. There we
I don't know.
go.
I heard that if you make all of your functions payable,
It's
that
like
you save on gas.
you save on gas, right? Because there's not a require there checking for message.value or something like that. I don't know. That's a level of, I would just leave it as your contract just to make
Oh yeah.
it
Okay.
yeah, just because like right now we're tinkering, we're not like, okay, so yeah, let's
Oh,
do function, let's call it get hash. Oh yeah,
oh, actually, hold on. Let me turn this.
It's pretty awesome. I mean, like
It is
maybe
awesome. You could show it up.
yeah, yeah, so
Okay.
we want to
Actually, you
get
know what?
hash.
Let's see what it says. Get hash. You
Yeah,
want to see
yeah, yeah. Let's see if
what it
it's
comes up
like,
with?
yeah,
Uh,
yeah, string memory input. We definitely want
oh,
that. Yep. And returns pure. We want all that. Yep. That's
all right,
perfect. That's
amazing.
what we want.
Wow,
Yep.
incredible.
Yep.
This is going to be really easy.
So that's going to do a catch act 256 of whatever our input is, right? And let's go ahead and push that out and let's make sure that all works.
It
Why
seems
is
to not
it
like the
not liking
input.
that?
Mm,
ABI encode. We need to wrap it in an ABI.
right.
Yeah. Yep. Yep. To go from string. There we go. I bet it's going to like that. And then we
Makes
could
sense.
even do like comma separated values there if we wanted to salt it or something like that. But for now, let's just make sure that this get hash function works.
Right. I forget. What do I have
If
to
you
do
go
now?
ahead
I
and
have to
yarn deploy probably,
right. Okay. All right. I've been in
and that'll
Forge land.
compile it and make sure everything's good for us. Nice, nice. Okay,
Cool.
and then over on the right, you'll go to debug contracts. And we've got a nice little get hash. So if you put in hello world there,
Nice.
and then hit send, we should get some
Cool.
like bytes 32 back, right? Okay. So in the process, you're going to come up with a secret. You would put it in here and you would hit go, and that secret would give you that hash, and you could put that hash then on chain, right? So we want to have
Right.
some kind of like save hash or register.
Yeah. Do we want a mapping or what do you think?
In this case, let's just make just a
Just
simple
do the
bytes
one.
32 value and call it commit. We'll make it very commit reveal-y, but this is the commit, right? And it'll make it public so people can see it too. So you'll do bytes 32 public. Yep. And then maybe let's create a function called like set commit, or we can't call it commit because we already have a variable named that. But yeah, probably just like set commit, do commit, attest.
And then
I don't know. And that would take in a bytes 32. Like underscore commit or something. Yeah, cool. No, it's not really your secret. It's like the hash of your secret.
right.
The secret will
Okay.
come in later. I would do
So
underscore commit. Yeah, or hash is perfect.
okay.
Yep. Any of those will work. And then we'll set commit equal to hash. And should we maybe even create a require statement there that makes sure that the commit hasn't been set yet? This whole smart contract is just for this one commit reveal, but we probably want to make it like you can't do a set commit if you, and maybe we would do only owner or something like that. IDK if we need an ownership pattern, but we could.
Maybe we don't need it right now because
Let's not worry about it right now. Yeah. Let's not worry about it right now. Okay, let's just push this out and let's make sure we can set our commit.
Actually, I guess public
Looks pretty good. Yeah, between public and external, what would that would be like, whether or not your contract can call it, right? It has to be called
Right.
externally. Yeah. So I guess it could be external and you could save a little gas there, but we're not. There we go. And you would take that hash and you would put it, oh, we need some
Oh,
money from the faucet real quick. So you'll, yep, there you
okay.
go. Now there we go. Okay. And then our commit gets
Very
set.
nice.
Okay, perfect. Perfect. So then we're going to have some kind of reveal function, right?
Right.
That will take in a string memory input, and public. I don't think we'll have
That'll
it
be
return
cool.
anything in this case. Yep. Yep. And then
Okay.
do open braces. And then what we need to do is let's get the get hash of it, right? So you would create a bytes 32 and call it the hash or something like that. Or
Right.
yeah. And then hash
Uh,
looks like, yeah, there we go. Yep. Something like that. We got some weird variable names, but it's working. Yep. And then you'll do a get hash of the input. And then you'll require that hash equals commit. And if it does, then we have the reveal and we'll have a new. Yep.
and
And then we'll have
then should we
some
emit
new
an event
public
or?
variable. Let's
Okay.
just have our string. Let's just create, we should have emit an event eventually, but let's just have a string public reveal, right?
Uh,
Nice. And then you'll set the reveal to the underscore input if it matches the thing, the hash. All right, let's test this out and see if it works, and then we're building the front end for it, basically. That should
all right.
be, those are like kind of the main mechanics.
Oh,
String
what's the
public reveal,
problem?
memory string. What's going on here? What the AI can't, the machine learning can't fix this for us already. So we're using let's see. Oh,
Identifier already declared. It doesn't like input. String public reveal doesn't like this.
reveal is the function name and it's also the variable. So you may need to want to, you might want to change line 21 to set reveal or something like that, or secret works. Yeah, that works. All right. All right. Cool. So
all
now let's
right.
say we go ahead and hit reload so we get kind of like a fresh view here too. Nice.
Okay, so let's say.
Right. Yep. And you'll put that in there. So we commit our hash and we tweet about it, and everyone can come see that we've revealed something at this certain block on chain. No one can tell what it is, but then we can then prove it later on with the reveal, right? By typing in that same string that you typed in to get there.
See if I get it exactly
Let's see
right.
if this works. Yeah, you have to get it exactly right or it fails.
Oh no.
Let's see.
Wait, we can just overwrite it, right? We can just say.
No, because you can't set the commit again. Like once we set the commit one time, it's locked. Let's redeploy the contract. Let's maybe like do like
What makes that
test the
so?
string. Because we have that require statement on. Oh no, we don't have a require statement. Never mind. You're right. We can totally. We should set it up so you can't do that. But yes.
Okay, so we updated it and then.
Same exact.
Wait, did I do that correctly? No, I think I did the wrong order.
No,
of
it did get
it
got a different. There we go. Now that reveal should work, right? Okay, so it is going to work.
Cool.
Okay,
it works.
So we do want to create a require statement on around line 18 that doesn't let you overwrite the commit, right? You can only commit once, because if someone commits something and then later on they can tinker with the commit, you really want that commit and that reveal to stick. You want this to all
what
be
is
like
the empty value that you test for for byte 32?
Require that, yeah, it's all zeros. It would be yeah, equals, and you do like 0x0, and then you do like 4 of them, and then copy and paste those 4 like how many times? 8 times.
Good question.
Yeah, I think so.
Gosh.
Wait, we can go get
There
the
we go. Yeah,
value.
I think that's good.
Okay.
What is? Oh
I
yeah.
don't think so. I think it needs to be
You don't think so?
more. It looks short. Let's see. How do we get bytes 32 0, right?
I think it was happy.
Oh, is it good? Okay. Let's test it out real quick and make sure it works. Like try
Yeah.
both the empty and the. You may be able to just do
So
not equal 0.
yeah, I was thinking. I don't know.
If you yeah. Let's check it. Can you
So
set
let's try test.
test? Yep.
And then
And we'll commit
set,
that. That worked. Now try
and then
committing it
we're-
again, and it should fail, right? If we try to commit that, yep, test 2, nice. This should fail on us. Okay.
That's good. Okay.
Be nice to get an error message. Oh, you should throw an error message in your require on line 18.
Oh, yeah,
Pay the
right,
extra gas for now. Eventually you'll use custom error messages, but for now we're just tinkering and figuring out. But it's nice to have that extra feedback, like what the heck is going on here. Try 0 while you're there. Just say commit equals 0. Okay, let's see if that, let's try that too. Ship another contract. Where are we putting this thing? We got to put this thing live too. Where are we gonna go?
Yeah, we got to put it on
Do we do like
Polygon?
Optimism or Polygon? Okay,
Sure,
cool.
Optimism,
Yeah. One of those networks.
I think I'll have to find that wallet, but I do think I have a little bit of
I can
optimism.
fund it. I can fund it. You'll just have to pull up a QR code as we go. But okay, so let's see.
Okay,
Make sure we can commit
so-
test again.
Okay, I'm gonna put this here just.
Yeah, so we have it. Good call. All right, and then if
Okay,
you try to
and
set it
then-
again, it should fail.
Why not?
Good.
This
Yep,
fails,
already committed. Okay.
And of course we can reveal.
Testing 1, 2, 3
Cool.
works. Awesome. And if you try to re-reveal something, oh, we have a require statement on 24 without an error, so you'll get a unknown. Yeah, you should get some.
Actually, we're not
revert
even.
Ooh, wait a
Interesting.
minute. Oh yeah, because
I guess it is the same. So if
yeah,
we
so
did,
if you put in, yep, exactly, that should fail.
fail.
Yep. Yeah. So you could
So
re-reveal if you wanted to. Yeah, I guess you could re-reveal if you wanted to, but it's not really that big.
we could do the same. We could do another require. I guess it would be a waste of gas for people revealing, but we could require that the secret not yet be revealed just on the basis of the secret having a value.
Maybe throw that in there just in case. Yeah, make sure secret
Right.
equals like empty quotes. Something like that. We're programming.
This. Look at us.
Look at us. Look at us.
Oh.
It may not. Oh, you may not be able to.
Do I have to do?
What do you have to do? How do you do a string compare?
How do you do like string? Can you cast it or something?
It's like one of those things I always have to just like go to Solidity by example and look at.
Yeah, for sure, for sure.
Like I've been doing this for how many years now? 4 years, and I still have to like go. We may need like some string utils, but we don't want to do that. That's way too much work.
All right, you know what? It's not that big a deal.
Yeah. Yeah.
Save that for
there we go.
Of the protocol.
Done. Solved it. Okay. So you've got a commit, you've got a secret. Let's how about like a tiny little bit of front end, just because we have a little bit of extra time. Like it's basically
okay. You're gonna have to teach me this. Yeah, please lay it
we'll
on.
do a little React, but it'll help. So if you go to your like example UI tab, there's some there you go. There's some kind of example stuff, and mainly there's that text box up above that lets you set the purpose. We'll steal that and we'll use it. So let's go over to your code and go to example UI. Yep, right there. Yep. And then if you scroll down, okay, so new purpose and set purpose, we can change that to like new commit and set new commit on line 19 there. Yep. And let's copy and paste that and do that same thing for reveal. We'll keep track of two different, oh man, it's gonna yell at us for a little bit. We'll fix it, don't worry.
For reveal, okay, just do it.
Yeah, we're gonna have two different boxes. We're gonna have a commit box and then a reveal box. It's gonna be a really ugly UI, but we'll make it work. Yep.
All right, I'm down.
There we go. So basically in the React state, we're keeping track of, and you could take out the loading ... IDK about that. Nice, nice, nice. Okay, so we're keeping track of some state variable for a new commit and a new reveal. And if you scroll down, there's an input on line 32. Let's copy and paste that. The input and the button. Okay, yeah, let's get it to just set the commit real quick. Okay, so yep, and then you'll set new commit. And then if you scroll down, there's a button and it's doing write contracts on line 42. Write contracts dot your contract dot set commit, I think is what the call we need to call.
Oh, set commit here.
Yep. And what we need to set the commit to is the hash of the thing, right? So we need to do we need to call, how should we do this? So what we need to do is we need to take our string and send it to the contract to hash it. I wonder if we could even keep track of another state variable. So if you go to on line 19, let's duplicate that. Yep. And let's call it new hash and set new hash or something like that. It's so funny. Like we've now spent as much time working on our React as we have our Solidity. The Solidity is like hella powerful, really cool. The React is just annoying and trying to get like the so here we are. This is the life of an unfortunate Web3 developer. Yep, full stack developer. Okay, so what we want to do is on change. See how we're setting the new commit on line 35. What we want to do is we're gonna go to our contracts and we're gonna hash that e target value. Yep, grab that right there where your cursor is, where it says write contracts dot your contract dot from line 43. We want to copy and paste that stuff. Yep, the stuff that's kind of like probably not even that much. If you just grab basically your we don't need any of this. Wait a minute. Let's just type it out because your thing will probably, let's just go to line 36. Sorry, terrible backseat driving here. Let's go to line 36 and let's do it like a probably line 35. Like grab it. There we go. And I would say let hash equal, oh, that's weird. Let hash equal, yep. And we're going to do read contracts. So we want to talk to our, read contracts dot your contract dot get hash. And we'll pass in the e target value, e dot target dot value. And then we want to set our new hash to that hash. There we go.
You like that?
Yeah. And then let's do so on line 39 to 40, let's put in so right between those two. Yep. Let's do some like squiggly brace guy, squiggly brace boy, and then do new hash, I think is what it's called. Let's try that out and see if it even works. Hopefully what we're trying to do here. Yep. Let's do new hash there.
Okay.
Yep. Okay, so now when you type in something in that box, what happens? Oh boy, I didn't like that. We might have broken it. Let's see. Yep. Okay, let's see what the error is. Maybe we need to check. Yeah. So what is it freaking out about? Oh, okay. We can't do. Let's see on line 36, what's it given back to us? Instead of setting new hash, maybe comment out line 37 and console log that hash that comes out of there. Maybe we need to do like a 2-string or something weird here. And then you'll just start typing a value in there and it, await, we need to await it. So
I see.
Yeah. So you'll need to make it an async function, right? So on change equals, and I think right there, right? You do async space. I think it goes inside I think it goes right before the E.
Yeah.
It goes right there, right? Let's see if it likes that. And then you'll need an await on line 36.
Oh, right.
Now we've put in twice the mental load into our front end as we have our smart contract, and we're still, oh, you'll need to do, yeah, there you go. Yep. Now let's see if we get a hash back when we type. There we go. That's what we want. All right, now do the set new hash to hash on line 38. You can uncomment. Now, as we type, we should get a nice hash below. All right, isn't that nice? Nice. And then when we say set purpose, let's go ahead and change the set purpose button to say set commit or something like that.
Or hash secret or
sure. Oh yeah, that's right. Hash secret. Yeah. Okay. Nice. Okay.
Although I guess we don't really need it.
Did it like hot reload? Yeah. Okay. So let's type in test, and let's go ahead and hash our secret, and that should put it on chain.
Not really putting it on chain. Wow.
It should. That's what, so this is like kind of why scaffold-eth is nice, is it's already wired up to your smart contract, and you're kind of like, yes, you're doing some dumbass React shit, but that React stuff is all tied to your contract pretty quickly. Already committed. So did we commit one already?
I'm just, so this should be updating, right?
Your balance. Let's actually, let's clear.
It's doing it as I'm typing, right?
Yeah, so it's calculating the hash. Let's redeploy the contract just to make sure.
Okay. Okay.
Try test and make sure it'll hash, like let us hash the first secret. Yes, okay, it did. So then let's provide some feedback in the front end about what the current commit is. And let me show you how to do that. So you'll scroll up. We're looking for hooks up here. Darn it. There aren't. We're looking for a specific hook called read. Okay, so what we need to do to get this example, we need to go to the app.jsx and grab it from there. Yep. Now, if you scroll down here, we're gonna, it's called use contract reader is what we're looking for. There we go. See how line 170 is what we're looking for. 170 is the money. Grab that and let's jump back to our example UI. Okay, and then at the top where we kind of are setting our other state variables, right up here. Yep. Go ahead and paste that in. We may need to include use contract reader, but yep, and then you'll set that, you'll grab the commit there. But yeah, make sure use contract reader is imported from hooks just to.
Why is it not happy about this? Oh,
yeah, purpose was there. Yep. So that'll be a commit, I think is what we're calling that. Yep. And then use contract reader. Oh, will it just like fill it in for us? Do you just like,
it comes from which one? From,
I think it comes from ETH hooks. You may need to go to app.jsx. Yeah, sorry about that.
That's okay.
There we go. Yeah, if you grab that like 10 to 3 line and kind of clean it up on your other, yeah, there you go. Nice. And let's get just the use contract reader. You can clean out those other things. Yep. Okay. Nice. And we want to read, what's the commit variable in the contract called? Because right now we're saying purpose, but I think we want to get commit. Perfect.
Yeah.
Yep. So let's read the commit from the smart contract and let's display it. So you need to change on line 23 there at the end of line 23, we need to change purpose to commit. Nice. And then after we have the button, so let's go down below the button from line 44, probably like line 69. Nice. Right after that, if you do little squiggly boys and do commit. Okay, and you could even like before that write like on-chain commit : or something like that. Like obviously we would want someone that's a little bit better at UX design to kind of take this over, but let's just make the prototype and get the thing to work. Okay, ooh, let's wrap it in a div, right? So it's like on its own line. Oh yeah, we're wrapping things in divs like smart contract developers don't like to do. All right. There we go.
Okay.
Now we're on. Okay, so we're starting fresh. We don't have. Yep, there you go. And then you hash that, and it goes. Oh wait.
Maybe we redeploy because we are not allowing you to commit twice, right?
Yeah, but why isn't it reading the commit? Let's go to the debug contracts and make sure commit is set. It is set. Okay. And then when we
Oh, okay, it is. Maybe it's just slow.
What?
Let's try
What
again.
was that? Okay, let's do a redeploy. Let's get a fresh shot at this thing. What the heck was that? Okay, and then maybe reload on the right. Maybe it's not hot reloading.
Interesting.
That is interesting. What the heck is going on here? What are we doing wrong here? Let's go to debug contracts real quick. And then hit reload. Yeah, see, it shouldn't. Okay, now let's do a yarn deploy again. Let's make sure the contract address updates here. Yep. So the contract is A51 first. Oh, reusing, son of a gun, wiggle wog. You need to do a -- reset like a peasant. I hate that so much. It gets everyone, it catches everyone. You should not ever cache on localhost. Okay, there we go. That was our problem. Okay, so we go back to our example UI. We've got a fresh one. Yep, now we can do test. Now if you hash that, we should start to see it as our on-chain commit. There we go. Okay, now awesome. we need to duplicate that UI, right? So we need another text box and another button that lets us do basically the same exact thing, but it will be to reveal our, wait, let's see. Hash your secret. Maybe we could just
you hash it, you commit. I mean, it's really not hashing. It's really, this should really be commit, would be clearer.
I think maybe we just need a second button. Yes. Right. Yes. I think if we copy that button and make another one, and really there's a lot of like weird stuff in that. Like you don't need a lot of that.
Yeah, we can get rid of some of this, right?
Yeah, exactly. Like all of it. Like everything, like we don't even really need the callback. I would just do everything like 50. I would do 51 to 61 delete. Yeah, that's good enough.
This one.
Yeah, there we go. Basically nothing happens in the update. Let's see if that works. But yeah, copy that, paste another one down.
Should I test it?
I
guess it won't work.
Maybe.
But...
Yeah. There we go. And then let's create a second button called reveal your secret or something like that, right? Nice. And then that's going to call not set commit, but set reveal. And it won't paste in the hash, it will paste in the string. So line 61 is what we're editing.
Our string called?
I think it's called
new commit.
New commit. Okay, so we didn't even need that new reveal. We over-engineered it. Right? We don't need that. Yeah.
Right with that.
Okay.
So I guess should we redeploy?
Yeah, let's deploy so we have a fresh contract. And now we're just like doing -- reset by default just because we don't want to mess with it. All right. So you commit that to chain.
Commit it.
Okay. And now you would tweet that, right? You would tweet the 4849 or like even the address of, hey, look, everyone, I've committed this. You can land here and see the commit. They wouldn't be able to see the string yet, but it would all be there. Now let's try the reveal. And we're going to need
maybe really the UI should have like a list of secrets or if it only has one secret, one.
Like unrevealed secrets. Yeah.
And then are we right? Yeah, I don't think we're writing that anywhere.
Set reveal is not a function. I think maybe we have something wrong with our, what's it called in the contract?
Maybe we did need set new reveal.
No, this is in the Solidity. I think we're looking.
Oh,
there's not a set reveal function. I think it's just called reveal. Yeah.
Reveal.
We have like no standards at all with our doing our contract. We're just kind of lowercase. There we go. And yep. Okay, let's try that. And that worked. Okay, so one last thing we want to do is display the reveal, just like we're displaying the commit. If you scroll up, I think we want to copy paste line 23. Yep, let's copy paste line 23 and have one called the reveal. There we go. And it would be reading the your contract. I think it's called secret, right? Because we called our function reveal. maybe just call it secret and not reveal on 24 also, like they're right there. Just to be, yep. And then down there where we have our commit displayed, let's display our secret. So keep scrolling. I think it's below our buttons, right? Where is it? Right there. Yep. Yeah. Copy that whole div and make another div below it and have it be the secret. All right, we got about 10 minutes
is like
to
magic.
deploy this thing, right? This is so cool, especially when you have that like ML like filling it in for you too.
Yeah.
All right. So let's start fresh. We have some. Oh yeah, there we go. Let's commit that to chain. We would tweet that out. We would show that off. We would send a link. Someone could go to our link. They could see this commit. Then you would later on reveal it. Test doesn't work. Great test there. And then hopefully Nicholas is great. There we go. So that's basically that little square right there is our entire app, right? And we carve everything out around it and just have the example UI be the whole UI of the app. We'd hand it over to a React developer. Someone would make it look really fancy in Figma and take 2 weeks to get this thing like into production. But let's just say that like all of that is done and we want to put the app into production. What network should we put this on? Should we try Polygon or Optimism? What I mean, it's 33. Come on, let's do Mainnet. Let's do Mainnet.
No, you're crazy.
Come on. Come on.
Let's go.
All right. So what you need to do to deploy to Mainnet is you'll need to do a yarn generate. You're going to need to generate an account.
It's going to ask me to do something else, isn't it? Oh, no. Okay.
No, yarn generate is all you need. And then you'll need to do a yarn account. So now there's a mnemonic. Be careful. There's a mnemonic now in there with your hard hat stuff. That's like a 12-word seed phrase. If you expose that, that QR code to me, if you can kind of like make it a little bigger, like stretch that terminal out so I can scan that QR. There we go. A little bit. I got it. Okay. And I'm going to send you $50 should be enough to deploy this, right?
No.
You think it's going to be more?
Generous.
You think it's going to be
be that much? I don't know.
I don't know.
How much gas? Do we have a quick way to figure out how much gas it's going to take?
Yeah, I mean, gas is at 34. What you could do is look at the deployment of in hard hat. You would look at the hard hat deployment and see how much gas it's using. So if you just do a yarn deploy real quick and then watch your hard hat node, then go over to hard hat there and you'll see there it was like 47,000. Wait, that's not right. It's got to be more than 47,000.
Is it
dash reset probably. Dang it, wiggle wog every time. There we go. So about 300,000, right? So 300,000 at the current gas price. I have a gas calculator here somewhere. Instead of calculating gas, we should just be YOLOing to mainnet. I can't find my gas calculator. Where is it? Here we go. So 300,000.
30 Gwei.
Here's a nice little ETH build if you would like to. If you follow that link in the, it'll be $90. Damn. Okay, we're gonna have to go a little bit. Let's see.
Let's do Optimism or something.
I already sent some. I think I sent 70.
Okay.
Okay, so you've got your. Okay, so we need to edit one other thing, and it'll be the gas price we run at. Since I want to kind of be a little bit more surgical with our gas. If you open up the hard hat config, you'll see a mainnet gas over in your file editor here. Hard hat is what you're looking for. It's like a hardhat.config.js or something like that. It's down right there. And then you've got mainnet gas line 31. And let's set it to like 27 and let's see what happens. Just do 27 there. There you go. And then let's go to your console and let's do a yarn deploy -- network mainnet and see what happens. Yeah,
Wild, man.
feels good, doesn't it? Feels good. Here we go.
Oh,
Dash
network.
dash network and then space mainnet. Yeah.
Space mainnet. Okay.
Yep. Come on, baby. Come on. All right, now we need the gas gods to be with us. And we've got transaction hash. It's a good start. Okay, but time is of the essence here. What do we have? 7 minutes left.
You only got to wait like an hour.
Is that what it's saying? Ah, dang it. Okay, let's speed this thing up. How would we speed it up? Just do a yarn. If you hit Control C and then hit up and enter, Wigawag should tell us that we need to speed up our transaction. Yep, increase gas. Wow. So hit enter. This is why that whole pain in the butt of caching the contracts, this is where it pays off, is when you're going to mainnet. All right. Now, if you hit reload over on Etherscan, we should see that a new contract, with the same nonce has been submitted. Oh, damn, I think a contract just got deployed.
Oh, perfect.
Wait, why did it say reusing? That was kind of weird. I think we just deployed a contract, though. That's the important part.
I think so, too.
Yeah.
Can we verify this real quick?
Yeah, let's, we could try doing a yarn verify over on the left. Just type yarn verify and see what happens. I'm not sure if this works. Nope. Ooh, the address. So do a space and then that A902. Please work. Dang.
API key.
Oh, it's saying you need to do -- network mainnet. All of that with a -- network mainnet.
At the very end.
I think so. Yeah.
Might actually work.
It's doing something. Okay, we need to do something. We need to get started on a yarn build. If you can get a yarn build triggered in one of your terminals, because that's going to take a few minutes to build our static site. And we would like to put this thing up on IPFS or something, some kind of URL that someone can go visit. Even like a yarn surge will work. It's trying real hard to verify it, isn't it? Because what we want is if you could send me the URL,
a secret.
And we could, yeah, exactly. You type a secret and send me the URL, and I land and see that like the secret, sure enough, is here.
We shouldn't have deployed it with the require that it can't be committed to multiple times.
Right. Well, we should have deployed it where it's like a mapping, and you can like set any sets of secrets and have this. But we did this all in 40 minutes, so
pretty good.
Is that yarn? You have that yarn build running? That's the important thing. We need to get that going. It's going. Okay, cool. Now you just need a faster machine.
I mean, it should be pretty good on here.
Yeah. I don't know what's going on with the verification. Maybe it's like Etherscan or something.
I think they're always backed up with verifications. I discovered recently they have I don't know, I'm not going to be able to find it right now.
They have so many fun tools digging around in the menu systems of Etherscan.
Yeah, let's see. Nope. I have like a feed of recently verified contracts.
Oh, look at that. Or AKA contracts to ape into. Ape reloaded. Ooh. Pool master. Painted MFers. Oh man, just a garbage feed probably.
Should we go find out what it looks like?
Yes, we should. Tell us more about these painted MFers.
Oh, are we verified? Hey, there we go.
We did it. All right, and let's see what our app. Yes, there we go. So now do a yarn surge. We could do IPFS, but let's just do yarn surge. And then it'll give you, fresh clouds.surge or you name it something else. Yeah. Secret machine. It's a secret machine. Hey, everybody, it's a secret machine.
I don't think we can see these painted MFers.
Yeah, I'm kind of disappointed by the painted MFers, to be honest.
Yeah.
Okay, so now, hold on. Let's go to secretmachine.surge. .surge.sh. And we've basically built and deployed an attestation app that's backed by a smart contract.
Crazy.
Ooh,
And if you want to spend the ETH to commit to it,
yes.
actually, maybe you should. Maybe you should commit a hash,
Should I
commit a
do it?
secret. So
Should
I'm
I
not
do
looking at
it?
your screen, so I can't see.
Okay,
So
let's
this will
see.
really work. This is going to be a good test. I can't.
Yeah.
I can't
Okay.
see what you're doing.
I'm pulling up the example UI. The thing is, this is not seeing that. Oh my, it's shoot. Okay, there's one thing we're missing here.
Oh, we didn't
The
build it with the right. We
app.
had to change the
Yep.
app.
Yeah,
Yeah. Okay.
app.jsx needs to be set to mainnet and not localhost. There's one change you need to make as an app developer, and you point your app at, there we go, mainnet. Yep. And then you'll have to do a yarn build
One other
again.
thing, right? Oh no, it's in hard hat was the only other change. Yeah. Okay,
Yeah.
this might take a second.
This will take a second. Let me holler at my next call. I feel like we should record to the end of this just to see it work. Let me
I think this will happen fast. Let's see. Let's see if that M1 Max can perform.
Go M1. I have my M1 sitting here and I just can't make the jump. I keep like starting projects over on my older computer and then needing to go back to them. It's terrible.
You're usually on a Mac already though, right?
Yeah. Oh yeah. Like just a procession of dead
good.
max. There we go. Then a yarn, your yarn surge, but you'll need to do the domain exactly the same.
Same or different?
I would do same. Yeah. Yep. What you can do is even do -- domain in the surge command, and it will. There we go. So secret machine is being overwritten, and then I should be able to see it. Let me tell this dude I'm going to.
Okay, it works. Right. UI is up when you're ready.
Okay. Okay, and I should be able to share the screen. I'm going to steal the screen from you.
Do it.
Share. Okay, you got it. Let's see. I'm going to hard reload on your app. There it is, right? This is the app that we've built. There's the whole thing. Okay. And we were using burner wallets, right? But now I have the wallet here. I have everything. If my wallet's like on the wrong network or something like that, your app is going to tell me right away that I need to switch. Like say I come in on Rinkeby. All of this stuff is kind of taken care of for you. You've built an app that works and you've deployed it and it's ready to go. Now I come in here and I have a secret that I want to put out here.
All right. I'm not looking at your screen. So.
All right.
I don't know what you're typing.
Oh, look. All right. I'm going to do. This is my secret. Okay. And I'm going to go ahead and commit that hash on chain. And it's going to cost me $5. Cool. And there it goes. Okay, so now I'm going to go ahead and clear that out. We should see a commit on chain. You should see it on my yours, right?
782F975.
Yep. Do you want to go ahead and share it and finish it off? And you said that anyone can reveal. Let's see if we can set it up so you can reveal. If you want to share it back. Yeah.
When you say share, what do you mean?
Share your screen again, just real quick.
Oh, got it. Just a second.
I mean, I can share my screen. I can reveal it on my screen too.
Weirdly, it won't work. Oh, maybe I minimized you. That's why. Okay. Yep. Sharing it back.
There we go. Okay. And then, yep, we go to secret machine. You can see that I've revealed that. Now try like hello world or something and make sure it doesn't work, right? Go hello world and try to reveal the secret. And MetaMask is going to tell you that transaction is going to fail.
Right, but maybe
you need to connect your MetaMask, and MetaMask's nice full address doxing. Let's just go ahead and screen share with your pants down. Thank you, MetaMask. Okay, so hello doesn't work, right? It should yell at you and say that's not going to work. Okay, now try revealing speedrunethereum.com with capital. Yep, you got it. Runethereum.com. That was what I was attesting to. Let's see if that reveals. Oh boy. Oh
Okay.
boy. And then you spend
Let's do it.
$5 and we
I
whoa,
guess
look at this
let's do it
cheapo.
high.
This is a live presentation. Come on, man. We're balling.
All right, let's do it.
So there we go. Like in about the time frame
Oh.
of an hour, we had the idea of creating this sort of attestation machine. We got in and we wrote the contract and we tinkered around. We tested a lot of the use cases. We didn't write a full test bank, but we tested kind of the edge cases and made sure it works. And then we built out a little UI that lets basically me come up with a secret, post that secret somewhere, post the URL. It's like a live URL of a live app that goes to that smart contract. And then you were able to come here and like verify it and try it out. And all of that happens on chain. Pretty dope, man.
Whole thing works.
Pretty awesome.
Whole thing works.
Yeah.
Very cool.
Good work. Good work. Good build. Hearts, Nicholas,
Awesome.
for coming along on this journey.
Thank you. This was great. A lot of fun.
Awesome.
And
all
on
right.
Mainnet,
I'll see
no
you
less. Wow.
on Mainnet. We YOLO to Mainnet. All right. Hearts.
All right.